Okay, so we're going to put this all together here and do a little bit of describing the properties of this quadratic here, which is an equation form. We're asked to find the axis of symmetry, the vertex, and identify if the vertex is a maximum or a minimum, and then describe if it opens upward or downward, and talk a little bit about the width of the parabola. So let's begin with the axis of symmetry. This is in standard form. So our formula here is xv equals negative b over 2a. And just being a little bit cautious of our positives and negatives, when we substitute, we'll have a negative 4 over 2 times negative 3. So that's really a positive 4 over negative 6. And we'll reduce that to a negative 2/3 for xv. Then when we substitute this into the yv, which we need to find the vertex. So technically right now we have the axis of symmetry, but we'll put that together neatly in a minute. So when you substitute this in, by the way, it doesn't always come out to be a fraction, so that's once in a while, and I kind of give us a more challenging one here. When we replace this in to find the y at the vertex, you're going to substitute in the negative 2/3, and notice the square is only on the x, so be careful of that when you're doing computation. So we plug in this x value. Everywhere we've got an x in the equation or the function, so plus 2, and then we calculate. Keep in mind that when you square negative, it becomes positive. So this becomes negative 3 times 4/9. And then when you multiply these out here, you're going to get 8/3 plus 2. And then here you're going to get negative 12/9 plus 8/3 plus 2. So when I reduce this here, I'm going to reduce this value. This is a negative 4/3. So when I continue to simplify this, I have negative 4/3 plus 8/3 is 4/3 plus 2, which is really the same as 1 1/3 plus 2. And that's going to give me a y value of 3 1/3. So right now, I've got an axis of symmetry, and sometimes you'll see me abbreviate it this way here, AOS, axis of symmetry. We write that as an x equals, because it's a vertical line through the x-axis, negative 2/3. The vertex, which is a point, and it will always have an x and a y, is at negative 2/3, comma 3 1/3. And so far we've done the axis of symmetry, we've done the vertex. We need to identify if the parabola is a the vertex is a maximum or minimum. So that means we have to look at the a value. The a value is negative. So the parabola opens downward, which means the vertex is at the top, making it the maximum value. And then the last piece, we've talked about it opening. The last piece is the width of the parabola. And so since a is greater than 1, we know that the parabola is going to be skinnier. And it seems kind of strange, but when we graph next time, we'll actually see how that affects the numbers when we're graphing, particularly in the vertex form. Okay, so a quick summary here. We have the axis of symmetry, which is the vertical line. We have the vertex. We've identified that the parabola opens downward because the a value is negative, making the vertex also a maximum value because it's at the top of the graph. And because the a value 3 is bigger than 1, the parabola is going to be skinnier than the parent. Our next example, which is supposed to be B here, is in vertex form. Okay, so here's the H, here's the K, and it is already set up, minus and plus, so the signs are already set to go. So our vertex, much quicker to identify now, is 3, 8. The axis of symmetry is at x equals 3. It's always the same value as the x on the vertex because it goes right through the vertex. And because the a is positive, the parabola opens up, and the vertex is at the bottom of the graph, which means the vertex is the minimum value in the entire graph. Again, because a is greater than 1, because it's a value of 2, this parabola is going to be skinnier than the parent function. The last example we'll look at is another example in vertex form. I wanted to give this one because this one's a little trickier because the normal vertex form is ax minus h all squared plus k, and if you notice the signs are a little bit different here. So that means in the parentheses you technically have x minus minus 4. And then, of course, this here is plus a negative 5 for k. So when you're identifying the vertex now, your h and your k, your h is a negative 4 and your k is a negative 5. So you want to be very careful with that because you're trying to line this up to the original form here, the general form, where that's supposed to be a minus and that's supposed to be a plus. So again, the plus 4 indicates we've got subtracting a negative 4, which makes the h value really a negative. And then our k value is negative. So then we have the AOS, axis of symmetry, is at x equals negative 4. This parabola, so because the a value is negative, this parabola opens down. And the vertex is at the top, which makes it a maximum value. The a value equals 1 here, even though it's a negative. The actual value, the number itself is 1, so it's going to have the same width as the parent. And in other words, no changes. It has not gotten skinnier or wider. And those are the properties of this graph.